Alright, we are all set to go for some more work on this situation. So, the next step in the process is to compute these two values here and here. Let's take a look at it. The harder one would be the second one. So we're going to do this one first. So let's see, first step they do is, yep, that has nothing to do with the amount of memory available. Because we have a minimum of 64K, and that's plenty of space to get the hot string, or the hot directory. See, here we have add item. Then we have another loop of add items. Alright, so we're doing folders. Not sure why that's like that. And then what we would have to do to get the x correct is we would have to take that plus 1 plus the size of a lister inode So let's see. That's just the user data pointer, I think, and I think that that's working because this is pre-allocated on the arena, so we know that that is going to be stable. Same idea here. So that's not more memory. So this is down here just 2 plus the length of the file name plus the length of the node. We add all those up. Then I think we have full file path. File name len. Okay, I think I see it. So, our first step is going to be we need this up here. Now all we have to do is compute x right here. Not sure why that always is one too much, but anyway. Alright, now I just need to see an example of the same thing down here. Okay, so this is kind of weird. What we're looking at right here is code that looks almost exactly like something I wrote in the previous part of the stream, but it's actually not what I wrote. This was written like a couple months ago, and I just happened to have a very similar style. The only reason I can tell that it's different is in the new one I did a plus equals and a minus equals here instead of these. But it looks like I have the exact same allocation strategy here as I used in that one. But point is, estimated string space size. So the idea here is we're saying here's the option count times the size of this, plus the size of the user data, plus the size of, okay. So the memory requirement for this thing here is the user data size plus the file list.count times the size of a lister node, and then we want to add in all of these. Here we want 1 for the slash, here we want 2 for the status. And you know what? I want an extra on each for null terminators. And then down up here, we're going to want one more addition for the. You know what? I want another extra for null terminators. And then file name len of the info. So you know what? I'm going to just boil this all the way down to that. There we go. Gary Johansson asks, any new thoughts on the Microsoft debugger? You're talking about WinDBG. Yeah, I do have a lot of new thoughts now that I've seen it. I haven't used it, so I can't really determine whether or not it's worth it to switch to Windows 10 for that particular one. But what I mean, my main question about it that I had yesterday is still unanswered because the video you sent me was just a demo of how it works. I didn't watch the whole video, I'll admit. They maybe go into my question later, but my main question still stands, which is just how are they actually doing it. But I do agree that it's a useful way to do the debugger, to do a debugger, I think. I think that's probably what debugging will look like in the future, And I mean, it kind of looks that way now with WinDBG, but like I think that's going to overtake Visual Studio on Microsoft or something like that. I think, yeah, I think it's pretty cool. I don't have any particular comments on WinDBG, I guess. All right. Now, in addition to everything else I just did, I need to be able to do this. What is this? Full path dot stir. That's for getting the buffer. Okay, so none of the memory in here needs to survive, so it's not like we accumulate an entire extra amount from this push array here every time. But this memory size does need to at least be reserved in addition to everything else. So what is this? This is the hot string size plus 2 plus the length of the file. So I think because this will never get filled beforehand, we can count on this to be the plus the file name length for any given one. So then the only thing we need to do is take memory requirement, and we want to add in I will be trying WinDBG on Windows 10 sooner or later to get more thoughts, though. So hot size plus 2. Okay. Okay, that should be enough memory for this one. Let's see if all that builds. Okay, so for the buffer list, things will be a bit easier. What I don't necessarily have is a buffer count, though. Right? Going into this, I don't necessarily have a buffer count. And I wonder if that is something I should just be adding to the API. Let me see if I have that. Here we go, buffer count. I don't remember that, but that's exactly what I need. Apparently it's getting used somewhere. I see. Okay, so now that I have a buffer count, I can compute a memory size just based on what I see down here. So, one thing I know the memory size will always need is buffer count times the size of a list node. There we go. And let's see, what else do I know we need? We probably need all buffers list output buffer. Oh shoot, I just realized why there's a space down here. 1, 2, 3, 4, 5, 6. I need 6 more characters per file. Whoops, that was 2 more. 6 more. Okay. So this one I need 1 per file, in addition to the buffer name length for the status, plus I need the 1 for the terminator on each, so that's 2 more, so 3 total. So, wait, why am I doing it like this then? Now, the only tricky part is right here we're just getting the buffer name by looking at the buffer summary and pulling out the name length, which means we would have to iterate all buffers once just to get their total length. Okay, what do we do? I'm already iterating files on the other one, so iterating buffers isn't necessarily the worst case scenario. I'm already iterating buffers twice. Down there I'm iterating files twice. Yeah, it's the same thing. It's fine. Well, let me just think. The only other option I can think of is that there is a good chance that there's a maximum size that might not be very high. So 256 is the max size, which is a little bit too big, because most of them are actually like, what, this one is less than 16 bytes, and so estimating with 256 would kind of be a massive overestimation. So let's just iterate the buffers. Oof, here we go. Okay, only remaining problem is all the ones that don't call list or begin new item set because they don't have a generate call. For instance, if we go to the spot where we were computing arena size earlier, and I mentioned that it looks very familiar. Yeah, so this is the only one where I'm computing arena size, I guess. This one, init lister state, init lister state, they're all taking in no third parameter, which indicates to me that they're just using the default size. Yeah. This one's computing its actual size by using the estimated string space size plus the option count to get that, plus the user data size. So what I think we want to do Alright. And that lets me call that and in here I never actually allocate the arena at all. So I think what I want to do is say where is lister and arena clear data and ensure bytes. Alright, here's where earlier today I wrote the exact same code as I already had. Just a couple differences, so now we can just change this into that's why I was pulling it out, by the way, in case anyone wasn't sure. And so I think the idea here is if the arena size is non-zero here, we're going to allocate it right away. But that doesn't quite work, does it? Because it's not actually that call that does the thing we most care about. So here's where we init the state. Here's where we first init the lister. Here we know the user data for the first time. I think that's where we want to send the arena size moving forward. So what we're going to do is we're going to say this is now the behavior of this function. And this doesn't do this. This goes here. Let's do about that. I'm just going to do +7 for now. It's the best thing I've got. Okay, so, by the way, in case that wasn't clear, what I'm thinking about here is the user data size. Technically, after you push on the user data, it gets rounded up to a multiple, like the alignment of the arena gets pushed up to a multiple of 8, lines on a 8-byte boundary, and so technically that could lead to a situation where we don't have enough memory in the arena. If, say, my user data size, for instance, had a size equal to 1 modulo 8, right? Or rather, I guess I put it, if the user data size modulo 8 is equal to 1, then you could easily get another thing with a certain size that exactly complements that. So something that's congruent to 7 modulo 8, and such that when they add up together, they are an exact multiple of like a 4K boundary, which is what I'm rounding to. Which means, for instance, it could add up to exactly 64K if you have the user data size plus everything else. If that's exactly 64K, and then user data size gets rounded up, we'll actually not be able to fit everything in anymore. So this +7 is for this. Technically, it's overdoing it, because if this is 8, then this should be a 0, right? But this guarantees I have enough in the absence of good rounding functions in the custom layer. What the custom layer is most missing is a set of like shared functions that are well organized, that have nothing to do with 4coder and are just here are your basic functions. Anyway. Lister first init. Now takes in the arena size. Now for these I can just pass in 0 because this is going with a refresh handler, and therefore its size is computed whenever it gets regenerated. Wait, what was that? With fixed options. Okay, here's where we need to start actually computing sizes. Alright, now we need to get estimated string size. I think that needs to come down from above as well. Okay. So again, this is just this. And, you know, it's enough of a pattern at this point, why not? Option count, user data size, estimated string space size. That actually made a longer line at the end of it, interestingly enough. Infos. Alright, and the reason I just made those all zeros right now is because they're already working, and we're default to rounding up to 64K, which means they're already working because there's already enough space for them in the basic system. So you don't actually have to do a string size estimation so long as you don't have too many strings. Kind of lazy, I know, but that's how we do it. Let's double check everything is working. We have to test literally everything. So, what's everything that just got changed? Don't care about all that shit. Switch buffers. Okay. Step 1. My arenas are still empty. Oh, because if I do that before I've ever allocated an arena... I guess I have to list or begin new item set twice, or maybe I should just... Yeah, how do we bootstrap that? Okay, I see what to do. Okay, here's the idea. If the lister arena base equals 0, we've never been allocated before, or right at there, let's do it this way. If the max is less than 64K. Then emergency, just do the update thing. So lister arena clear data and ensure bytes. Make sure I have at least 64K. Well, what else does it take? App. It needs app. Cool. Let's try this again. Boop. Boom. Okay, so that's working. Boom. Uh-oh. Base does not equal 0. Yeah, so its base does not equal 0. That's true. Is it getting double freed? Is that what's happening here? What's going on? No, it's not getting double freed. So what? This memory pointer here is just... it's not on the heap. Yeah, so there we're freeing stuff off the heap. Up here we're freeing stuff off the heap. But when we get it, what we actually do is we call memory allocate. Yeah. So all we have to do is stop doing that, switch over to see if it's going to kill us to pass app into that. Nope, this is fine. Okay, so that's all working. Nothing bad there. Okay, so now it's slow, but that worked. And it's pretty fast once it's loaded. Okay. Hey, that solved that problem. Alright, so... done! Finally. Still got more testing to do though. We changed a lot of stuff. We gotta be more thorough than this. We gotta be even more thorough. Here's opening the color tweaker. Okay. Yep, this is working. What else could I test? Let's see. I changed the fixed option stuff. So let me open up some nonsense and edit it, and then go, hey, I want to kill this. And what do you want to kill? Oh, I want to kill this. That's just failing. That's weird. Okay, gotta look into that, but this one still works. Yes! Okay, that's working. Suppose I just close. Yes! Okay. So the next trick is, why does the kill not work anymore? Let me try something first. Okay, so that does work. So the only time it fails is if I'm right here in, where's lists? Here it is. We want to find the kill, not confirm kill, I want the actual kill buffer call. Sure to kill, confirm close, kill buffer. Here we go. Alright, we come in here and, oh, we want to kill something? What is it called? Oh, buffer 13, let's take a look. Kill buffer. Well, I don't really want to see that. Kill buffer. And the result is do sure to kill. Okay, so this is beginning a new lister, and then we're finishing. I see. So this is one of those cases where the finish actually needs to go first. This is like the command lister. Yeah, the command lister works in such a way that when you activate it, you call this first, and then you do all this business. And the reason for that is that this can begin a new UI mode. Same thing has to happen, whoops, not there, here. Because this can begin a new UI mode when we call kill buffer. If I do lister default and then use the user data, isn't that going to fail? Shouldn't that be impossible? Oh, the user data is just a pointer in that case and an integer in this case. That's why these are fine. They would only fail if they were pointers and I was going to dereference the pointers, but they're not pointers into the arena, right? If they're pointers into the arena and I was going to dereference them, that's one thing. But I'm not dereferencing pointers in the arena. In this case, I'm literally never dereferencing it. I'm using it as an integer. Here, I'm not technically dereferencing it. I'm calling it, and it's a pointer to memory that wasn't in the arena either. Okay. Good catch. Yes. Cool. Alright, I think everything's working. So, I think that's a good spot for a commit. Okay. Wait, what happened in the jump lister? Did I have to get an arena size? Did I... Activation didn't change. Get the user data, params. Open the jump lister. Does anyone know what I changed here? Ah, it's one of these things. Okay, got it. Cool. Call this fixed file buffer lister crashes when list very long, for very long lists. Fixed kill buffer on dirty buffer bug. Cool. Alright, so let's get back to the to-do list and let's see what happens next. I think I should do open large projects next because I suspect that that one is fixed now. I think that was the same bug as this other one, but I want to just double check. So I'm going to go reread the bug report, make sure that I understand it correctly, and then we're going to try to repro it. I think the people on that thread offered a repro case, so it won't be too hard. Okay, so the idea here is these folks have provided this generate batch script. And if I run that, it looks like this. Okay. Yeah, no problem. I have to assume that the reason it was crashing for them was the same as the reason the listers were crashing before, which is that the list gets long enough that it just can't allocate the space it needs for the nodes. Alright, I'm going to update on this bug real quick. Recursive. Alright, so updated that thread about that particular bug, and I'm going to check that tentatively. Alright, so the next thing we're going to do, let me check something quick. Okay, I'm going to cut this stream off here and restart in 10 seconds, because this was basically the end of part 2 of the previous stream. They were thematically the same topic. We're about to go to a new topic, so I figure let the two-parter be 2 parts without extra stuff on the second part that is unrelated. So, I will be back in just a second. Thanks for hanging out, and bye-bye.